This is a quick recap of Section 1A, Lesson 1, Parent Functions. So we have 7 different types of parent functions that we learned about. So from the definition, a parent function is a function in its most basic form that shows the relationship between the independent variable and the dependent variable. Basically what that means is it's the most basic type of equation of that kind, so there's no types of transformations. We haven't added anything, subtracted anything, multiplied, divided, anything like that. So soon we're going to talk about transformations, but for now we're talking about just that basic graph, all right? So for linear, it's y equals x. So you need to know that y equals x is linear. You also need to know that it makes a line, so you need to be able to graph this line if you are just given y equals x. Now you're always welcome to make a table. Okay, but what you need to know is that it starts in the middle and then it goes up 1 over 1, and it just creates this straight line. The domain is all the possible x values. So if we look at our x-axis from left to right, on the left-hand side we're going to negative infinity, on the right-hand side we're going to positive infinity, so we could have any x values. The range is the possible y values, so bottom to top. So on the bottom, again, negative infinity, going all the way to positive infinity. So linear is very basic, just that diagonal line. Positive slope, slope of 1, stuff like that. Quadratic, so if you are given y equals x squared, you need to know it's quadratic. You need to know how to graph that. So if you need to make a table, again, you can make a table, okay? But it always is going to start at 0, and then you're just squaring those x values. So if x is 1, you multiply by itself to get 1. If x is 2, you multiply by itself to get 4. Same with the negative. So if x is negative 3 times negative 3 gives you positive 9. The domain and range. Domain are possible x values. We could put any x in here for x, right? Like we could multiply anything by itself. So negative infinity to positive infinity. Our range is all the possible y values. So if we look from bottom to top at this y-axis, we have nothing, nothing, nothing until this point right here. Well, at that point, the y value is 0. Like it's possible for the y value to be 0. So we have a bracket around 0, and then those y's go all the way up to infinity. Cubic, y equals x to the third. If you are given y equals x to the third, you need to know it's cubic, okay? Same thing as before. If you need to make a table, make a table, all right? But you're just multiplying the x's by itself 3 times. So negative 2 times negative 2 is positive 4. Multiply that by another negative 2, and you get negative 8. So if you're putting this in the calculator, you're going to make sure you use parentheses, okay? So if you're practicing this at home, you would put parentheses negative 3, parentheses exponent of 3. You could also just do negative 3 times negative 3 times negative 3. But anyways, this is the table you get. When you plot the points, it creates this interesting looking curve. This might be the first class that you've seen it, but the domain is all the possible x values. Once again, you could put anything in for x here. It doesn't matter. If you put something in for x, you're gonna get a y out. So the domain is negative infinity to positive infinity. Same with the range. The y values, if I look at my y-axis, I'm starting at negative infinity and I'm going all the way to positive infinity. So any y value is going to show up here. Any y value that you could think of, let's say we could think of the y value of 3. If I go to 1, 2, 3, it has a corresponding point. So negative infinity to positive infinity for the domain and range on that one. Absolute value. Okay, y equals the absolute value of x. We should be really familiar with those bars by now. This is the most basic function of absolute value. So again, if you need to make a table, make a table. But you just take whatever x value you could think of, make sure it's positive, and that's your y value. So the absolute value of negative 4, for example, 1, 2, 3, 4. If I were to take the absolute value of negative 4, I get positive 4. There's my point. Okay, so you could put any number in for x. If we look from left to right on our x-axis, I go from negative infinity over here to positive infinity over here. So our domain is any x value. Our range is a little bit different here because I have nothing, 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 nothing until this point right here. It won't let me click on it, but it's that very bottom point. Okay, the y value there is 0. So when we are talking about range, we are talking about the y values. So the lowest possible y value is 0. And it goes all the way to positive infinity. Exponential. Remember, technically the parent function for exponential would be y equals b to the x. That gives us 3 variables. We don't know how to graph that. So what we do is we're going to graph y equals 2 to the x. Okay, so if you're given y equals 2 to the x, you need to know it's exponential. Exponential means the exponent is x. Okay, exponential exponent is x. Once again, you could make a table. Okay, 2 to the power of 0 is 1 because anything to the power of 0 is 1. 2 to the power of 1 is 2. 2 to the power of 2 is 4. And if you were to put these numbers in your calculator, you would notice that this is getting closer and closer and closer and closer to 0. No matter what number you put in for x, you are not going to get a negative back out. Okay? There's never going to be a negative y value here. So our domain, our x values, well, we could put anything in for x, right? You could put any number you can think of in for x. If we look at our x-axis, we go from the left to the right, negative infinity, positive infinity. The range is where this one is different because we are approaching 0 and approaching 0 and approaching 0. We're never touching the x-axis. We're never even going to cross the x-axis. We're not going to touch it, but we can get super, super close to it. So we do 0 to infinity with a parenthesis around the 0 because it can't actually be 0, but it can be super, super, super close to 0. So you can kind of see we're approaching 0 over here, and for our y values, we go all the way up to positive infinity. Last two, start with the square root. Okay, you should be familiar with this symbol by now. Y equals the square root of x. There is an imaginary 2 right here. You're never really going to see that written, so just know that if you don't see anything, it's an imaginary 2. Okay, so when we take the square root, we cannot take the square root of a negative number. All right, that is going to give us an imaginary number that we don't know how to deal with right now. So when we are looking at x values for our square root, we have to start at 0 because we can take the square root of 0 because 0 times 0 is 0. We can take the square root of 1. 1 times 1 is 1. We could take the square root of 2, but that's going to give us a decimal, and we don't really want to deal with that. So we're going to take the square root of 4 because that's the next perfect square because 2 times 2 gives you 4. You'll also notice that this is just the backwards version of quadratics. So if we look really quickly at this quadratic graph from 0 down, it's the backwards version. Notice how we don't have the negatives for square root, but we do have all the positives. So the square root of 9 is 3. You can see we graphed our points, as many as we could on this. When we come to the domain, all the possible x values, well, if I look from left to right, I have nothing, 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 nothing until this point right here. At that point, the x is 0, so our domain is 0 to infinity. Again, have to have a positive x value. And our range is going to be the same thing. If I look from bottom to the top, I have nothing until that 0. I'm going to go all the way to positive infinity. Last one is the cube root. It is literally this cubic table. It just has flipped the x and the y's. Right? So we flipped the x and the y's for this cube root. This is what we end up with. We did pick specific x's so that we could get integer y values. So the cube root of negative 27 is negative 3. Cube root of negative 8 is negative 2, and so on. Okay, it looks just like that cubic graph, but turned on its side. So our domain, our possible x values, well, on the left-hand side, we go to negative infinity. On the right-hand side, we go to positive infinity. And for our range, we're going down and down and down. You can't really tell, but that is trending down on those y values, and then it's trending up. So negative infinity to positive infinity. So a lot of the domains are negative infinity to positive infinity. The only one that's not is the square root. So please, when you're graphing them, make sure you're paying attention to what your domain and range are. And that's parent functions. So those are the 7 parent functions that we learned.